just doing a live session video on some immunology stuff, prepping for Monday. So we're going to start with an overview, and then we're going to go ahead and maybe do a little bit in depth on maybe the complement system. So we'll see where we go. And all right. So first off, if you get an injury in, all right, this is my version of a hand today. All right, so if you get an injury in your hand, then you're going to have some bacteria and or viruses or other things get in there. And if we had no defense systems, then that would mean that eventually we'd be toast. They'd just spread forever. Okay. All right, so if we zoom in on there, we know that in the tissue, so here is a blood vessel that's near where the cut is. And we're going to say that this is the cut right here. Okay, so this is outside. And there's a lot of enemy things, as well as some damaged cells that just when the cut happened, they cut through the cells and made so that they broke. So we'll say that there are some cells here and the cut took out that cell and they're going to dump some stuff. So the presence of cell contents as well as bacteria and viruses is going to be detected by, generally we're going to have some mast cells are a specific type of cell that is in the skin, and then similar to mast cells we have basophils, which are going through the blood. Okay? Okay. So those will detect that there is an injury, and they will begin doing so they put out three things, which one is histamine, one is leukotriene, and one is heparin. And these three things combined, one of them is anti-clotting. Heparin is anti-clotting, which is what lets so the immune system can get in. There's not a clot blocking it. Other things, the histamine is going to make so that your blood vessel gets bigger right there, and so then you have more blood flow in that area. And what travels in the blood? Just about.
You have red blood cells, white blood cells, the plasma
proteins. Yeah, plasma proteins. Good. So white blood cells, if there's more blood there, it makes it more likely that a white blood cell is going to be there because there's more blood, and that's what carries them. It also makes so there's going to be more plasma proteins and all that kind of stuff. And so that's why we want to do vasodilation and have more blood there.
Right.
So, as that happens, so some different things will happen simultaneously. So we're going to have some clot formation going on that's trying to stop too much blood from getting out. And so right at like the major site, we'll have some clot formation. So I'm just going to put clot. And then upstream a little bit, like we already mentioned, we're going to have anti-clot. And it's doing both. So it's trying to slow the blood that's exiting the body while still leaving enough of an opening for
the first responders to get in.
Yes, the first responders to get in. They're the white blood cells. And lots of white blood cells can actually grab on to the edge of the blood vessels, and they can roll along. They grab onto the edge of the blood vessels like they have an anchor, and then they have another anchor, so they roll, and every anchor keeps catching as they roll along the side. And so that's why they only need a small opening. You have enough blood flow to get them close, and then they have the anchor thing that'll put them through the small opening. Then you're not losing a ton of blood, you're also leaving an opening for them to get through. Everybody's happy. So hopefully that helps make a little bit more sense about how that kind of clot, but don't clot,
Right.
is working. Yeah, first responders, mast cells, and basophils, and then the next thing in is probably going to be a neutrophil. And right now, all of what we're talking about, if we're talking about first response, we're pretty much going to be talking about innate immune system. Okay, so far we have mast / basophils, and I say / because they're almost identical, except one lives in the tissue, one lives in the blood. So, and those release their three things, H, L, and H, which is heparin, histamine, leukotriene. So, histamine and leukotriene and heparin. So, once those show up, the next thing is going to be neutrophils. All right, and the neutrophils, they go in and they are going to phagocytose, so they're going to eat bacteria primarily, because that's what's going to be floating around in the outside. Viruses will be hiding in the inside. We'll get to them in a sec. So this is a bacteria. I'll shade him red because he's evil. All right. And the neutrophil is going to make a divot and just like phagocytose. It can phagocytose, or it can do a DNA trap where it shoots out strands of DNA. So let's say that there's another bacteria over here. And so it's the two things that the neutrophil does. One is phagocytose, the other one is a DNA trap, and it shoots out actual DNA, which is really kind of interesting. And the DNA makes a kind of net that keeps the bacteria from leaving the site. Why do we want the bacteria to stay there? Lots of reasons. One is we don't want it to infect other areas. Another one is if it's all in one area, you only have to bring your immune system to one area, and so you can concentrate all your troops in a single area. So this is a DNA trap. And honestly, that one's just kind of fun to remember. And the neutrophil will spray defensins, which is just a molecule. It's just a molecule. It'll spray defensins into the DNA trap. And the defensins will damage the bacteria, and it might even kill some of them. All right, so far we've gone over two molecules. Two major cells. We've gone over the mast / basophils and then the neutrophils. So without looking at anything, if you can, go ahead and tell me a little bit about each of them. So what would be the first thing? Start with their name.
The mast cells and basophils release histamine, leukotriene,
Good.
and heparin.
Great.
And then the neutrophils phagocytose the bacteria.
Mm-hmm.
They also put out the DNA trap to keep all the bacteria together so it doesn't spread all over the body,
Mm-hmm.
and shoots defensins into the net.
Great. Yeah, that's...
What do defensins do again?
Defensins harm the bacteria. Exactly how, I'm a little vague on, but they do, so they can kill some. So that's a little first view. I'm going to go ahead and pause this video. So hopefully that was helpful. One sec.